First question asks whether the graph opens up or down. So what I'm looking for is, I'm looking for the sign of that number. I can see that it's positive, and so it opens up. And then for the vertex, I can see that I'm looking at these values here, the 5 and the -8. And so the vertex is going to be 5, -8. Okay, and then so we can draw that out. So 5, -8, and it's opening up. So let me erase that real quick. Just something like that. Now I need to find this intercept, the y-intercept. So to find that, I plug in x = 0. So if I do that, I get 2 times 5 squared minus 8. So that gives me 25, 50. 50 minus 8 is 42. So this crosses the y-axis up here at 42. Let's actually do something like that. Okay. The minimum or maximum value of the function, so the lowest y value that it achieves is here at -8, which is the y-coordinate of the vertex. And the axis of symmetry, that's going to be this symmetric line, which happens when x = 5. The domain of the function is all possible x values that will give me a real output. So any x value I could put into that. So the domain is all real numbers, so -∞ to infinity. And the range is all the y values. So it looks like it starts at the lowest y value that it achieves is -8, and it goes to infinity from there. So -8, infinity. Next, I want to use completing the square to write that quadratic function in vertex form. And so I can see f of x is equal to x squared plus 8x. And then I'm going to write plus blank minus blank plus 7. Okay, so I need to think about what it is that I want to pull in there. So I can see that the term here is an 8. And so what do I want to add? I want to add here 8/2 squared. And I want to also subtract that. And so when I do that, 8/2 is 4, squared is 16. And so that gives me x squared, or sorry, I can factor this part. To this part here will factor. And it factors to x plus 4 squared. Then I have minus 16 plus 7, so that's going to be minus 9. And so the vertex, so now it's in vertex form. So we get f of x is equal to x plus 4, quantity squared, minus 9. Then it says find the vertex of that quadratic function using the vertex form. So the vertex formula says that h is equal to -b/2a. And then I can, so let's see what that is. So -b/2a. Okay, so that's going to be negative of -64, so that's positive 64, over 2 times 4, that's 8. And 64 divided by 8 is 8. So that is the x-coordinate of my vertex. And then I can plug that into my function f to find the h. F of 8 is going to be 4 times 8 squared. 8 squared minus 64 times 8 and then plus 107. So it looks like negative 149. So it looks like the vertex is 8, negative 149. Problem 4 says a long jumper leaves the ground at an angle of 20 degrees above the horizontal at a speed of 11 meters per second, and its height can be modeled by that, where h is the height and x is the horizontal distance. At what horizontal distance from the point of launch does the maximum height occur? Okay, so let's see here. We're doing something like this, and he takes off here. So x is the distance traveled in the horizontal, and h is the height. So this is the actual path that the jumper jumps. And so here what we can do is we can use put this in vertex form to find the vertex of this jumper. So what horizontal distance from the point of launch does the maximum height occur? So we can find that vertex. We know that h is equal to negative b over 2a, and so that's going to be negative 0.364 over 2 times negative 0.046. So I got 3.956. Let's say round to the nearest hundredth. 3.956, so that's 3.96. So this happens at 3.96 is where that vertex is. And then what is the maximum height? So I can take that and plug it into my height function. And so I got 0.72, and the height is measured in meters. And then what is the length of the jump? Okay, and so the length of the jump will be this distance plus this distance, and since it's symmetric, we can just double that. So the length of the jump is going to be 2 times 3.96. So that's 7.92. So that's there where he lands. The last one says gas mileage is tested for a car under different driving conditions. At lower speeds, the car is driven in stop-and-go traffic. At higher speeds, the car overcomes wind resistance. The variable x gives the speed for a compact car, and m represents the gas mileage. Okay, and it must be that there are questions on the next page, so I'll do that when I get to that page.